When we mix things together in a chemical laboratory, what we are mixing together is most often not solids, it's solutions. It's a solute dissolved in some liquid, which is called a solvent. The solute dissolves in the solvent. And depending on how much solute is dissolved in how much solvent, that's called concentration. There are many, many ways of measuring concentration. There's molality. There's parts per million. There's parts per billion. But the one we are going to talk about is molarity. That is by far the most common method of measuring concentration. Now, the definition of molarity: moles of solute over liters of solution. Okay, so let's think about this. It's the moles of the thing being dissolved over liters of the whole thing. Not the liters of the solvent, but the liters of the whole solution. This solid we're dissolving in the liquid, usually water, has some volume. So it's a small distinction, but it's an important one. So if something is, say, 0.5 molar, and that's how they would say that, 0.5 molar, it means there's 0.5 moles of whatever it is over 1 liter of solution. So let's say you had a saltwater solution. That does not mean there's 0.5 moles of salt over a liter of water. It means there's 0.5 moles of salt over a total volume of 1 liter. Now, the important thing for our purposes is math with molarity. The most important thing to remember is molarity times volume equals moles. And of course, moles leads us into stoichiometry, and as we know, everything is stoichiometry. So molarity times volume gives you moles. Always true. So if I said I have a 0.25 molar solution of NaCl and I have 0.500 liters of that solution, moles per liter, cancel the liters, and that gives me 0.125 moles of NaCl. And then I can go on from there to whatever it is I need to go. If I needed to make a half a liter of a 0.25 molar NaCl solution, then I would take this 0.125 moles of NaCl and convert it into grams, and then I would know how many grams to dissolve in water and dilute up to 500 milliliters to get the solution that I desired. If I need to do stoichiometry, let's say I'm mixing this 0.25 molar solution with something else, then I can start with that many moles of NaCl and dump it right into my stoichiometry. The other thing that gets people confused with molarity is dilution. If I have 500 milliliters of a 0.25 molar NaCl solution, I wanted, say, 300 milliliters of a 0.15 molar NaCl solution. The equation for that is MV equals MV. That is, these two solutions have to have the same number of moles of NaCl, and I know that M times V is moles. So 0.300 liters, right? 300 mils is 0.300 liters, times 0.15 molar is going to equal the molarity of my original solution. This is the new solution. And over here, this is the molarity of the original solution. 0.25 molar. But I'm not using this 500 milliliters. I'm not using that at all. That's what I'm solving for. So now once again, I take out my handy dandy calculator. 0.300 liters times 0.15 divided by 0.25 gives me 0.180 liters, which is 180 milliliters. So that means I would take 180 milliliters out of that original 500 milliliter solution, put it in a new container, dilute it up to 300 milliliters, so add 120 milliliters of water to it, and then I would have 300 mils of my 0.15 molar solution. You'll notice nowhere here did I work with the grams of NaCl. If you're doing a dilution problem, that's not what you do. You're really thinking, how much do I take out of the original solution, and how much solvent do I add to that original solution, to that piece of the original solution, to get up to my new volume.